Hello students, lesson number 6. You are welcome to this audiovisual tutorial on acceleration time graph. The audiovisual tutorial is presented by Abdulhafiz Ahmed. Please pay attention as the presentation proceeds. At the end of this audiovisual tutorial presentation on speed, velocity, and acceleration, the student should be able to 1. Define the acceleration time graph. 2. Explain the slope of the acceleration time graph. 3. Explain the area under the acceleration time graph. And 4. Use the equations of linear motion to calculate the area under the acceleration time graph and the slope of the acceleration graph. To be able to achieve the stated objectives for the lesson, the following content will be discussed. 1. Definition of acceleration time graph. 2. Slope of the acceleration time graph. 3. Area under the acceleration time graph. And 4. Calculations on acceleration time graph. While listening and watching this tutorial, you may come across these terms. Number 1, acceleration, which is the rate of change of velocity with time, or description of an object's velocity. 2. Displacement, which means the distance traveled in a specified direction. 3. Uniform speed, which means the ratio of S all over T, which is constant throughout the journey. Number 4. Velocity, which means the rate of change of displacement with time. Number 5. Acceleration, which means the rate of change of velocity with time. Number 6. Time, which means the time taken throughout the journey. ms per 1 is pronounced as meter per second. Number 8. kmh per 1 is pronounced as kilometer per hour. kmh per 2 is pronounced as kilometer per hour squared. ms per 2 is pronounced as meter per second squared. Now, the acceleration time graph describes an object's velocity the same way the velocity time graph describes. The same way the velocity time graph describes an object's displacement. Acceleration time graph shows the acceleration plotted against time for a particle moving in a straight line. The acceleration time graph plots acceleration values on the y-axis and time values on the x-axis. The vertical axis in the acceleration time graph represents the acceleration of the object. In the given graph below, reading the value of the graph at a particular time will fetch you the acceleration of the object in meters per second squared for that moment. Slope of the acceleration graph. The slope of the acceleration graph represents a quantity known as jack. Jack is the rate of change of acceleration. In the given acceleration graph as shown below, the slope can be calculated as follows. Slope is equals to rise all over run, which is equals to delta A over delta T, which is equals to A2 minus A1 all over T2 minus T1. Area under acceleration graph. The area under the acceleration graph represents the change in velocity. In other words, the area under the graph for a certain time interval is equal to the change in velocity during that time interval. Area is equal to delta V, that is change in velocity. Example, the graph below shows a constant acceleration of 4 meters per second squared for a time of 9 seconds. Solution. Acceleration is defined as A is equal to delta V all over delta T. By multiplying both sides of the equation by the change in time delta T, we get delta V is equal to A times delta T. Substituting the values in the equation above, we get delta B is equal to open bracket 4 meter per second squared close bracket times open bracket 9 seconds squared close bracket, which is equal to 36 meters per second squared, which is equals to 36 meters. Multiplying the acceleration by the time interval is equivalent to finding the area under the curve. The area under the curve is a rectangle. This area can be found by multiplying height and width. Height in this case is 4 meters per second squared, and the width is 9 seconds. Area, which is equal to open bracket 4 meters per second squared times open bracket 9 seconds squared close bracket, which is equal to 36 meters per second. The area under any acceleration graph for a certain time interval gives the change in velocity for that time interval. Example, a race car driver is cruising at a constant velocity of 20 meters per second. As she nears the finish line, the race car driver starts to accelerate. The graph shown below gives the acceleration of the race car as it starts to speed up. Assume the race car had a velocity of 20 meters per second at time t is equal to 0 seconds. Find the final velocity of the driver when she reaches the finish line. Solution. You can find the change in velocity by finding the area under the acceleration graph. Delta B is equal to the area, which is equal to half times s seconds times 6 meters per second squared, which is equal to 24 meters per second. This calculation gave out the change in velocity during the given time interval. To calculate the final velocity, we need to use the definition of change in velocity. Delta V is equal to V2 minus V1. Substituting the values in the equation, we get V2 minus 20 meters per second is equal to 24 meters per second. V2 therefore is equal to 24 meters per second plus 20 meters per second, which is equal to 42 meters per second. Therefore, the final velocity is 42 meters per second. Dear students, in this lesson, we have successfully discussed acceleration time graph, the slope of the acceleration graph, the area under the graph, and the graph shows a constant acceleration of 4 meters per second squared for a time of 9 seconds. Having successfully discussed the acceleration time graph, there are no further questions. Let us practice the following questions. 1. What is an acceleration time graph? 2. How can you determine the slope of an acceleration graph? 3. How can you determine the area under the acceleration graph? 4. How can you calculate the slope and area under acceleration graph? 5. A car driver is cruising at a constant velocity of 20 meters per second. As he nears the finish line, the car driver starts to accelerate. The graph shows the acceleration of the car as it starts to speed up. Assume the car had a velocity of 20 meters per second at a time t is equal to 0 seconds. Find the final velocity of the driver when he reaches the finish line. For further readings on the formulas we discussed, the following references may be contacted. Number 1, PNOKK, FNOKK, SF Akande, 2011, Macmillan Nigeria Publishers Limited, current edition. 2, G.O. Iweluka, 2010, Calculations in Physics for Senior Secondary Schools, African Fast Publishers PLC. Number 3, O.E. Farinde, H.E. Hemitella, and S.K. Dada, 2018, Essential Physics for Senior Secondary Schools, Tonat Publishers Limited. For Values 2022, via https:// byjuice.com/physics/distance-time-graph/ 5 https://www.tof/app.com/ask/content/concept/velocity-time-graph-208251. We have come to the end of the audiovisual presentation for this week. Meet me same time and same station next week. I remain your regular presenter, Abdul Hafiz Ahmed. Bye for now.